Okay. Good afternoon.
Afternoon, sir.
So,
Afternoon, sir.
Afternoon, sir.
okay. Okay. So, um, as posted in e-learn, no? So we'll discuss sample problems on uh, linearity, superposition, um, Thevenin, Norton, and what is that? Maximum power. So the questionnaire is posted in the forum. So kindly check that out, no, para masubay nato ang problems. Anyway, so let's begin with number one. So number one is a problem on linearity. Okay, so it says use linearity to determine V sub O in the circuit of figure 1. So assume V sub O equals 1 volt. So we're given a circuit which, if we inspect it, is linear, since it consists only of linear elements. Okay, so being a linear circuit, so we can use the proportionality principle in order to arrive at the actual value of D sub O by assuming a value of 1 volt. So how do we go about this? So with the assumed value of 1 volt, we'll work our way towards the source and determine the value of the source that will give an output of 1 volt, okay, at the output terminals. So using proportionality principle, so we'll be able to figure out, okay, the exact value of V sub O using the exact value also of the voltage source, which is given here to be 8 volts. Okay, so let's proceed with example. So kindly direct your attention in or towards this solution. Okay, so we're assuming 1 volt to appear across the terminals of this 3 kilo ohm resistor. Okay, so okay, what we need to find, I've said, is the value of V sub S that causes 1 volt to appear here. So we begin with the equation that will give us V sub S. So V sub S, okay, is the voltage of the source, no? So that is equal to the total current times the total resistance. So we've labeled the current I sub 1, and the resistance R sub T is the total resistance as seen from the terminals of the source. Okay? So therefore, we need I sub 1. We need to calculate somehow I sub 1 and R sub T. Okay, we can gather from by reducing this to a single resistor. Okay, so we begin here with the given, no? So we're given V sub O equals 1 volt. Okay, so by knowing the current flowing through here, we can work our way towards the source to determine I sub 1. So using current division, we have I sub 3 here. This is the source through the output. Okay, so using current division theorem, I sub 3 equals 2000, where 2000 is this combination. Okay, by transforming this, not transform, but combining these two resistors in parallel, 3 and 6 kilo ohms, the result is 2000 or 2 kilo ohms. So this current times the parallel resistance of 2000 divided by 2000 plus 3 plus 3. So we have 6000. Okay. And knowing VO to be 1, or assuming VO to be 1, okay, we can gather the value of, or we can solve for the value of I sub 3, which is 1 over 3000. So using this value in this equation, okay, and then expressing, so you can solve for I sub 2 here. Okay, so I sub 2 can be determined from this equation. Okay, these are all, there's no other unknown except I sub 2, so we can get I sub 2 here. Okay, so current division theorem can also be applied at this node. Okay, so let's call this node A and B. So this is current division at node B, and then current division at node A. So at node A, using current division, I sub 2, which is this current from A to B, node A to B, that's 3000 in the resistance opposite to the branch. Okay. So this whole thing is in parallel with this 3 kilo ohm resistor. Okay, so current division 3000 times I sub 1, which is the total current entering this combination, all over 3000 plus R sub 2, where R sub 2 is assigned as the current, as the resistance of this, the total resistance here, no? Starting from A. Okay, so that is 3000 in series with the parallel combination, which we combined earlier, 2000 and 6000. So the result is 4500. Okay. So knowing R sub 2, we insert that in this equation. So we get 3000 I sub 1 all over 3000 plus 4500. So now we can equate equations 3 and 2 to solve for I sub 1.
Excuse me, sir.
Okay? Yes?
Pwede ba daw maka-record,
Wala.
sir?
Ay, oo. Sorry.
Thank you,
Anyway,
sir.
thank you for reminding. Okay. Okay, thank you for reminding me. So, nalimot kita. Record. So anyway,